the end because you don't have any potential energy at the end because the pendulum's all the way at the very, very bottom. So this is the pendulum that is swinging back and forth, and so it swings down like this, okay? And then it goes back up. So this is your potential energy up here. This is your kinetic energy down here. Well, I'm now going to plug in the formulas. For potential energy, it's mgh. And for kinetic energy, it's 1/2 mv squared. Your mass for the pendulum is equal to 0.225 kilograms. Now, you'll actually realize that that cancels out because you'll see that there's m's on both sides of the equation. So you really don't need it, but just to let you know, you go ahead and put that in there. Gravity is actually going to be 9.8. Now, the height, what you're going to have to do is, since the actual tabletop is down here, you're going to have to measure the original height of the pendulum off the table. So this is going to be height A right here, and this is going to be height B right here. So to get your change in height, you got to subtract B minus A and make sure that that is in meters, okay? Now, once you get that, now you have to figure out what the velocity is. The velocity is a little bit tricky to find because the velocity equals distance divided by time. Well, the distance is actually the diameter of the pendulum, and the diameter of the pendulum in this case, when we looked at the vernier caliper, was 0.0256 meters, I think. And then the time, it depends on how far you pull it back, so that's going to be given by the photo gauge. Okay? So most people are going to get something like 1 or 2 meters per second when they get the velocity, and that is on the back of your worksheet. Now, what you're going to pray is that when you calculate the ones on the very back of the worksheet, number 7, you're going to hope that number 7's potential energy, when you do mgh, equals number 8's kinetic energy of 1/2 mv squared. And so, mv squared. And if those two things equal each other, then you know that you just proved the law of conservation of energy. In number 9, it says to compare the two, I would just find the difference. So what is the difference between potential energy minus kinetic energy? And you hope that that number is 0 if you proved the law of conservation of energy. So hope you have a great day, and that's your Conservation of Energy Lab. Bye. Love you.